Okay, so I am about to explain how binary search works in my my code in REPL.it/Kobe1Boss binary search main.py. Don't forget, whenever you do this, main is always where the code works. Okay, time to start. Import math. Import math is I am allowing the function math to work in my code over here. So math.floor is rounding down. So I return the floor as x has an integer. So this is the largest whatever. That does not help. It rounds down instead of rounding up, which would be just the word round. N equals this. This is my list. This is the numbers that I will be searching through while using the binary search. The binary search is everything past that, and this function over here is the binary search in which I look for the numbers in the list. Okay, so def bin, P is the number I'm looking for. M is the median, which is the middle number. Mi is the minimum, which is the lowest number possible. Ma is the maximum, which is the maximum possible number. If the minimum is higher than the maximum, meaning if the smallest number is bigger than the highest number, which isn't possible, then I print the number is not there because it isn't, and I return -1. -1 is just a way of saying that it is not there. But if the NM, which is the medium, the list in the medium, which is 6 right over here, because that would be right in the middle. So a median is right in the middle of any set of numbers. If that equals P, which is the number I'm looking for, which is over here, and O is I'm asking what number they're looking for. So if that is equal to P, then I return M. I return the middle, and I tell them that is the order in which they're looking for. It is the 0, 1, 2, 3, third number. But if NM, which is the middle, is actually less than, then I will cut off this part. This will be cut off from the list, and I will search from there. So how I type that is return binary, P, the number I'm looking for, math.floor, rounding down, which is the maximum plus the median. If I do the maximum plus the median divided by 2, so the maximum is 8 and the median is 3, okay? 8 plus 3, which is 11, which would be half of it, 5.5, but I can't do 5.5, so it's 5. So the maximum must be 5. Well, actually, no, the median must be 5, because that's over there. So P, the first comma, that's what P is equal. The second comma over here, that's what M is gonna equal to. The third one, that's what minimum is gonna equal to, and this is what maximum is gonna equal to. The minimum is going to be the median, the middle number plus 1, because once I use the median and all the numbers below it, they're all gone. I cannot use them anymore because they are no longer useful. I have already checked all of them and they do not help me anymore, so I chuck it off the list. And the maximum stays the same because the top number is the same, and the only thing that changes is the lowest number possible. But if you switch it around and you say that NM, which is the median, which is 6 right over here, if that is actually bigger, then you do the exact same thing as this, except the exact opposite. You cut off, before you cut off the one part of it, and now you're cutting off another part of it. So before you cut off the bottom, here you're cutting off the top. The way you're doing that is P, the number you're looking for, which cannot be determined yet. Math.floor, rounding down the minimum plus the median divided by 2. So since it's the maximum plus the median divided by 2, this is the minimum plus the median divided by 2. The minimum before, which was kind of 0, it's that plus the old median divided by 2. And because of this, the maximum goes down, but the minimum stays the same because we have the same minimum. And but this is equal to the median. A median is the minimum plus the median divided by 2. So that's 0, the median divided by 2. So it's basically 6 or 3 divided by 2, which is 1. So now we check 1, but we'll leave that later. And if that isn't the number, that means we're gone. Nothing left to do. And the maximum is the median, just like we said before. All this is garbage. We've already checked all of that. We don't want it. And we do the median, that minus 1. That's the max. That is the middle. That's the minimum, and this is the middle. So whatever we do next, so let's say that isn't it, and it says it's higher, then we know it's that. Lower, if we know it's that. If it is, we'll know it's that. And this way, I ask what number they are looking for, and I set that variable over here to bin o, comma, the rounding down of len, which is just the numbers in here. It's just that. So it's 1, 2, 3, 4, 5, 6, 7. That's 7 numbers. So len is equal to 7 times n, 7 of the list divided by 2, which is actually 3. So 0, len, n minus 1, which is why this is recursion. Recursion is when the function is being called inside of itself. In that way, in the end, it keeps changing the number. So if I have minus 1 and it says bin minus 1, it will keep going minus 1, minus 1, minus 1 again and again because it's in its own function. And that is why recursion is helpful instead of for loops. So there, I explain it. I hope I remember whatever I'm saying right now. And I'm going to run the code, see how it works. So I can ask for any number I want, and it will look for it and see what order in the list it is. So if I ask for 4, it will say 1, because it goes 0, 1, 2, 3, 4, 5, 6. That is the end of the recording, and thank you for listening to yourself.